Good afternoon, everybody. We're back and looking at language integrated query, and we're going to be taking a look at a couple of topics under there. We want to take a little look at the link method syntax equivalents for the kinds of things we've been looking at so far with the query syntax. Everything that we have done in query syntax can be done with method syntax. Method syntax allows for a few extra things, though, and that is especially so in regard to working with aggregates. So we're going to take a look at the aggregate methods that are available to us when we're working with link. So go ahead and grab your workbook. We're going to be taking a look at a few of the different example items that we're going to be working with. Give me a thumbs up once you have your workbook ready. And I'm going to actually jump straight to one of the samples called extensions and delegates. So in this one, I've got a few different examples of items. And I want to start off with looking at a demo with regard to extensions. One of the well, first of all, let's start out with the basis of absolutely everything. What is a computer program? A computer program is a set of instructions for manipulating information. Okay, take a little look around you, see if there's anybody in the room. If you're all alone, say it along with me. A computer program is a set of instructions for manipulating information. Okay. In similar manner, a class is a blueprint for creating objects. And classes describe what an object looks like and how it behaves. If you consider the built-in data type of string, there are a number of characteristics on that data type or that class. It's a built-in keyword string, but behind the scenes, there's actually a capital S string, wrapper object, and strings have certain properties. For example, you can find out the length of a string. Let me just go, I'll comment out the demo extensions just for a moment. And I'll just do this simple little thing. If I say var characters, character count is equal to my name is Dan Gilliland dot length. Length is a property on there that will give me the number of characters in that string. And if I go ahead and dump that out to the console, I will see a result 24. I can even give that a little bit of a title. Another thing about strings is that, well, actually, let me just generalize this a little bit. I'm going to create a string sentence that's equal that. So sentence is a data type string. That means there are going to be certain methods that are available on that. So for example, if I take a sentence and I split it based upon the space character, I can find out how many words there are in the string. By the way, give me a thumbs up if you have ever used the split method of a string. In JavaScript, yes, okay, but not in C#. So it's available in C# as well. How about this? Thumbs up if you have ever used the quack method of a string. One of you? That's because you had me over the summer, didn't you? You ran the query, so yeah, just now. One of the things you may find is that string does not naturally have a quack method. In fact, if I go, well, it doesn't naturally have a quack method. It will in this particular file because I've defined it as an extension method. So what is an extension method? An extension method is a method that you can write as a programmer to make new methods that aren't part of the original class definition. And so when I look at the string class, what I discover is that the string class or the string data type was written by Microsoft. And I don't have access to the source code for the string data type. You know, I can't change it and recompile it. But if I want to have some kind of a method on it that does something with a string object, I can do that through my extension methods. To create an extension method, you just simply have to use a static class and create static methods that have a reference to the data type that you are extending. So this reference right here identifies that we are adding a method to the string data type. And of course, you can call the variable whatever you want. I called it self because that's kind of a good name for it. So I can find out if a string is blank by just returning string.is null or white space on the self, on that object that already exists. So that is a static method that exists on stuff, but this will allow me to call isBlank on any instance method. Or if I want to air quote the string, then I can use the air quote method. Or, as I said before, if in terms of making it quack, I can go and have the string dump out a quack. So I can make these data types of mine give me extra information. The power of that is evident when we want to have certain data types to do certain kinds of things. So, for example, think of the notion of collections. So I've talked about collections. I've talked about the fact that there are different kinds of collection classes, and there are certain things I could do with collections. I could potentially want to do counting of items, or a whole host of other tasks with those. You'll find that the link method syntax is basically a whole library of extension methods on collections. I'll just comment that out and bring this in for a moment. On the demo extensions, I have some random text that I'm typing. I do a quack, some random text that I'm typing, quack, 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 some random text that I'm typing. So when I said text quack 5, that's how I got those different items out. Or in the text to be or not to be. So if I do a regular dump, but if I do an air quote and then do a dump, I get the quotes around it. Let's go and create a new item, and let's put this as C# statements for our new query. And let's just do something like this. Let's create a string. And I'll call this my sentence. And what should I do as a good sentence? To be or not to be. Whether it is nobler in the mind to accept the slings and arrows of whatever the rest of the quote says. Nice long string like that. I can take that sentence and I can break it into words. Oh, yeah, I can break it into words, and I will go and say var words is equal to sentence dot. Let's do a couple of things for this. Let's do a quick removal of a bunch of items. Let's remove some punctuation and remove the question marks, and let's remove the period. And then let's all put this to lower case. Then let's split it based upon the space. Cannot convert from string to int. Oh, why did I say remove? Replace. That's what I meant to say. Replace those items with empty strings. And let's just take a little bit of a look at the results that we get. Now, imagine I wanted to do a where query on this. I could get the words where for each word. If the word starts with a T, I'll get that. And then I will dump the results as words starting with T. And so here's all of those words appearing right there. Where is an extension method. So if you've got the IntelliSense paid for part of LinkPad 6, when you hover over where, it'll tell you that this works giving an IEnumerable of string, and it is an extension method that filters a sequence of values based upon a predicate, based upon something being true. So a predicate is essentially a function that determines if a certain condition or state is true or false. And so the true or false statement is this one right here, whether the word starts with T. For each word, if the word starts with T, then that'll return a true. If it doesn't, it'll return a false. So I'm only selecting the ones where it returns true. Selecting the words where it returns true. If you've seen us using that where clause in link query syntax, that essentially translates down to this method syntax right here. So in my extensions and delegates example, I've got a demo for that extensions to show, first of all, how extensions are kind of created with my extension classes. And then I'm also showing how we can use an extension method with a simple linked list. So there is a forward-only linked list. Let's see if I have that here. Let me go and collapse these a little bit. I created a couple of classes for demonstrating. Oh, that's not what I wanted to press. Escape. Stop. That back down. I created a couple of classes to represent the notion of a linked list. So here's a linked item, and a linked list is basically the kind, a forward-only linked list is basically the kind of a thing where I can have a bunch of items and there'll be a link to the next one in each of these, but not a link to the previous one. So I can go to the next and to the next and to the next. So a linked item of whatever it may be, a generic type, can have that type for the item and then have a next to the next linked item of T, and it has a constructor for the T contents. So with my forward-only linked list, all I need to have is a link to the very first item. And then from that, I would be able to, with my forward-only linked list, keep going on until the next item is null. So every time I add a new item, I need to basically find out if if the first one is null, then this item, or this linked item, I should say, that link becomes the first thing inside of there. And just also so that you know, the item would be inside of each one of these different kinds of things. So I add in an item, make a linked item out of it. So it's got a dot next, set it to the first, but the next item that's brought in first will not be null. So then if the last item is equal to the first, or sorry, I set the last item equal to the first, and then I keep going until the last item dot next is not equal to null. I'm going to be traversing or traveling along the chain till I get to an item that has null inside of there, and then I would be able to turn around and create my next link in that chain. Interestingly enough, if you've been thinking of your regular list of T, this is somewhat similar to a regular list of T. So what I did with this, so here's an example of that. So if I create a var first new linked item of int 5, first dot next is a new linked item of int 7. Here's the first dot next. So as far as the extension methods are concerned, I threw on something to create a count, an item count. And it becomes an extension method, an added thing onto my forward only linked list. So what I do is I just simply find out if find the links. So links start with the self dot first, as long as self is not null. And then it just simply loops through to the next link and counts up all of those items and returns the count. So let me show you then how the demo works. I create a code race winners, forward only linked list of string. And so I add TB, CLR, FA, ABD, and WLW. I can say that what's the item count of the coding race winners. And I can see that there are a number of winners. So let me go and show you what that one will give us. So there are 5 winners. I take the coding race winners, the actual object itself, the forward link list, I dump that. And in the title of it, I say how many winners there are. So here's the first, then the next, and then the next, and then the next. So the first one is a TB, CL, R, FA. I can click on that to get the actual next item. ABD, WLW, and then null. Questions or comments about again about extension methods? Actually, what I'll do is I'll get a quick little thumbs up if this is the very first time you've seen extension methods, just so I get a gauge of where people are at. Because I don't know if you were ever shown these kinds of things by your 1517 instructor or any other instructors. Yeah, most of the extension methods that you'll run into are ones that have been created by someone else. Yeah, and so you'll see them in other programming languages as well, like Swift and that. So it is a concept that's available in a number of programming languages. Linked item. So linked item is indeed a class. Let's go back to that one. So linked item is indeed a class. And a list, even when you think of list of T is also a class. Just like my forward only list, linked list of T is a class. What it uses is it uses composition, or it uses the whole notion of having a bunch of items in the list, or a bunch of items or a bunch of objects in the class that have references to other objects. Remember, a class is a blueprint of how an object behaves and what it looks like. It's a blueprint for creating objects. And the nature of those objects and how they behave can be simple or complex. Good question. So what is that T doing in there? That T is what becomes a generic placeholder. So let's go and make some notes about that. Linked item is what we call a generic class, that it supports working with um, objects of different types, data types. So T in this case is a placeholder for whatever data type you are wanting in your linked item. So by way of example with that, I could turn around and say something like linked item of int is equal to new linked item with, let's say, the number 5 in there. Sorry, I forgot to make my variable name. Linked item, a number is equal to a new linked item of 5. So essentially what I'm saying is that the data type of item here is an integer. Or I could have a linked item of strings. Or I can have a linked item of cars. Or I can have a linked item of students. It's almost like the index in a for loop, almost, but not quite. It's more like the var part in the for loop. Even that's a little bit, yeah. Maybe I'll hold off on that notion. But it allows you, with generics, it allows you to have different kinds of things. So when you had, for example, a list of, if you had a list of product, then that means every item in that list is a product object, because the T part, that substitute, has been identified as a product object, project data type. Good questions. So don't be surprised if you've got a few gaps in your understanding of a number of these things. Yeah, so in the forward only list, everything has to be of the same data type as the T. And that would actually, and I'm going to clarify that even a little bit more, of the same data type or subtype, matching subtype of it. So this part right here is the constructor. And you know that when you define your parameter list, you have the data type variable name. Well, when I declare for a number to be a linked item of T, that means that the data type that's expected right here is my integer data type. So if I tried to say linked item of T, a number is equal to a new linked item, and then I try to pass in a string like Bob, it'll say that's a compile time error because string is not an int. Okay, I'll throw a little bit of screenshot into the chat again. So let's talk a little bit about delegates. A delegate is a data type that defines the signature for a method, which really is talking about the return type and the parameters. So with delegates, we have the ability to assign a method to a delegate variable. So let's take a little bit of look before we get into the void demo delegates. Let's take a little look at some of the items I've got here. So first of all, I want to draw your attention to the delegate itself. So I use the delegate keyword. So class is a keyword for creating class data types. Delegate is a keyword for creating delegate data types. And what a delegate is a method signature that identifies the parameter list. So the key things are the parameter list, and also with that, the return type, the kind of information that it will return. So my computer is basically something that can take in a whole bunch of values, and it will return a double. Now, on line 174 and 181, I have candidates for the computer delegate because they match the signature. They take in an array of integers and they return a double. So an adder is going to do the work of adding all those different numbers, and an averager is going to look at doubling the numbers. Once I have the delegate data type, where'd my mouse go? See if it shows up. Okay, guess I don't. Once I have my delegate data type named, I can use it as a data type to declare a function that I can call. So I call my computer. My computer is a method, and I can pass in as many numbers as I want. So I'm passing in 1, 2, 3, 4. Let's take a brief little look and see what the body of the adder does. So I've got an array of values, an array of integers. I do a for each, and I just total them all up and return the total. The averager does the same thing, but as it totals, it counts how many there are, and it returns the total divided by the count. Therefore, in my demo, I've got a bit of sample code that I've got commented out. But if I call the display computation method that I had below, pass in the adder, so it can add the 1, 2, 3, 4. It'll use the adder computer. Do the averager, it uses the averager computer. I can declare my own instance of my delegate inside of here. And so I can say that this is basically a multiplier, my anonymous delegate. Or I can even go and do my delegate inline as a lambda expression. One more there. Okay, we're going to take a little bit of a break now. We'll take a break until 2 o'clock. In the meantime, I want you to create an entry in your journal for the image I've given you in the chat. Basically, that's the screenshot of the void demo delegates method. And I want you to put in your own words what is happening on lines 146 through 159. And essentially, you should be able to like for every complete statement, you should be able to create a single sentence. And if you can translate what you're typing in code into English, then that's going to be a big help in terms of exercising your ability to understand the code. So with that in mind, I'll see you guys in about 12 minutes. No, the input does not always have to be a list. It does not. I just made a list so I could do something interesting with a bunch of data. Good question, though. Okay. See you at 2. Hello, everybody. I'm back from my nap, and we're ready to continue on with the second part of today's class. I want to go and take a little bit of a look at some of the aggregate method extensions. So I'm going to open up number 17 in your link query syntax demo. In this one, we're once again connecting up to the Westwind database, and I've just got a little hodgepodge of different items in a main method just to sort of show the extension methods that give us different capabilities. So, for example, we have the .count method, which gives us a count of how many items are in our collection. So when I say categories.count, that is effectively giving me how many categories there are. I'll just highlight that part and select it. And I can see I've got 8 categories, 8 rows of information in the categories table. And another little sample of the product stock count, where I see that I've got 77 products in the database. Now, one of the things about the count method is that the count method can take a predicate. So remember, that's something that gives us the ability to kind of filter. It gives me a count of only those things where the product name contains chef. So doing a product count of that will give me only 2 items in the database that fit that criteria. By the way, the equal greater than sign in this is the lambda operator. And so you essentially, it follows the lambda expression, follows the grammar of having your parameters, lambda operator, and your return expression. Now, when you call a particular method, you have to use whatever expression type that it is looking for. Many times when we're doing things with filtering, it's going to be some kind of a predicate where the result has to return a true or false. One of the other things about a lambda expression is that it effectively works as an ad hoc or on-the-fly anonymous method that we pass into the count method. So this thing is a delegate. It is a method that returns a Boolean, takes in one parameter, and from that one parameter, it returns a Boolean value. So we can read something like that as count each item such that, that's a phrase I use for the lambda operator, count each item such that I only include items where the product name contains the text chef. That's what's happening up there. So count is one of the aggregate methods. By the way, when you think of an aggregate is simply a single value that you get out of a number of other values. So the count of items would be an aggregate. You get the single value or the sum of items or the average or the maximum and the minimum. All of those work on collections and they produce a single value of interest. So some of those other methods that we have include, as I just alluded to, are sum, average, max, and min. And here I've got a bunch of examples. So here I'm going through the order details and I'm selecting the unit price times the details quantity. So the quantity times the price, or the price times the quantity, minus the unit price times the discount times the quantity. So getting the line item total less the discount. So order totals giving me all of this information here gives me for each of the order details, it gives me that line item total. So out of all of those, I can see the line item totals and order details, and I can see how many there are. So I'll do a count. There's 2,159 order detail line items, and the grand total of all of that is $1,267,108.04. So it's a small business. I know you're thinking to yourself, $1 million, that's a small business. Yeah, that's a small business. Pretty small. Probably can't handle too many employees. Remember, that's the gross sales, not the net. You have to take off the cost of the products themselves. So I can get the sum. There's the sum of all those items. I can get what the maximum is. And the largest line item total, the minimum or the average. So if I do it for all of those, I can see that there were 2,000 line item details totaling over 1 million, where the average line item amount is $586.90. The largest line item total is $15,810. The smallest line item total is $4.80. So that's quite a range of line item totals. Some people, when they go through the McDonald's drive-through, all they do is they order a sausage McMuffin, no egg. Other people go through and order these big meal things. So the difference between what you pay at McDonald's can range from a little over $2 to 25 bucks, depending upon what you get. So those are all examples of aggregate methods. That happens too. Next time you go through McDonald's, try ordering a large Coca-Cola, hold the cup. See what you get. Okay, let's look at some other examples. Here's one. And notice now that our problem statements are starting to get into the realm where we have to do some kind of aggregate calculations. So let's focus just on our problem statement. List all the orders showing the order ID, the name of the company, the freight charge, and the subtotal with no discounts, as well as the subtotal of the discount. Now, in this particular example, I'm also showing the actual line items, just so that you'd be able to see those. But what we would be wanting to do in terms of getting the and actually after this one too. This one I'll just maybe move down to put just before the line item count, so that my main focus was the order ID, the company, the freight charge, the subtotal, the discount subtotal. And what I'll do is I will comment out these ones. And I will get a result that would look like this. So the order, the company, the freight charge, the subtotal. Notice the freight charges are varying widely as are the subtotals. But if you're wanting to sort of do a bit of a mental check, you can also go in and comment in some items. So if you want to see, okay, there are 3 line items and the total was 440. There are 2 line items here. The total was 1863. 4 line items here, 2490. Or if you wanted to see all of the items themselves, you can bring it in like that. And then you can do a format, collapse down to one nesting level. And then if you're interested in seeing, okay, these 2 items, they had 9 of $18 stuff and 40 of $42 stuff. Okay, that explains why the price is so high. And notice also that my sum here is doing a link expression on the inside. It's not a predicate this time that returns a true and false. Rather, it's a link expression that returns numeric value. So the sum is a method that is expecting a decimal return value. That extension method expects whatever's inside there to be calculated out to be a decimal. Here's another example. Show me the company name of each supplier with a count of how many products that supplier provides to us. Also do a breakdown of the product counts by category for each supplier. So that one becomes interesting. Like the first part was probably might come across as somewhat straightforward. If you start with suppliers, and by the way, when you're looking at doing the aggregates, it can be really helpful to see. Let me bring that up here. And move it over there, maybe shrink it just a little bit. But because I'm wanting to get the product counts of the supplier, it makes sense for me to start my from clause with my suppliers because it has a natural collection. So each supplier can have many products. So that means when I go through the navigation property, company for the supplier, and the products, that's an actual collection, I can get the count. Or if I push that in just a little bit more and resize this a bit so I can fit that over top there. Maybe hide that whole portion. I don't have a thing to hide it. Probably have a view. No. There, that's not bad. So let's think about this again. So I start my query from all the suppliers, and then each company is a single supplier. For that, I can get the dot company name, and then I can get the dot products and account. And then I can do a query, since products is a collection. There's many products. I can go from each item in the company products, and I can group the items by the item's category name into a product by category. And then I can get that category name and the count of how many of those products there are. And I go and run that. I can see that some of my companies provide beverages and condiments and produce, meat, poultry, produce, seafood. Now, some of them provide a number of different products, 4 products under the condiments. Here they've got exotic liquids has a total product count of 3. 2 of them are beverages, 1 of them is condiment. So most of these are real specialty kinds of items from my suppliers. Very small set of different products that I would have. By the way, thumbs up if you are taking or going to take the business intelligence course. Yeah, taking that right now. Okay. See, with business intelligence, they want to gain some understanding of what's happening over large swaths of data. So of course there are tools for that, like you're learning about in the business intelligence course. But there's also an aspect where we can provide and get that kind of information as developers as well. So sometimes we're going to be tasked with a question that maybe the tool doesn't really give us an answer to right off the bat, but we can write a little program to help with that. Here's another one. Oh, we looked at order totals already. Yes, we did. Okay, then let's take a look at some of the other extension methods that we have. So we saw extension methods for aggregates, and there are extension methods for all of the link query clauses. So some of the extension methods that we would have include like for the select clause, where we can put into here a lambda expression saying what it is we want to select. There is the where clause, where we put in some kind of predicate of the filtering that we want to have take place. There's a group by clause, which has a lambda function to identify the things you want to group by. And there's, I think it's a group by descending, or no, not group by, I'm thinking about order by. So that's group by, and then there's order by, and the order by descending. So all of those things that we saw within our query syntax has an equivalent method syntax. In addition, there are a number of other methods such as first, last, first or default, last or default. And this particular demo here shows that whole list of different items. So I'm going to take a little look at this part for the select. I can see all staff. So the employees.select, getting just first name and last name. Notice the data type that comes back as well. It's an I-ordered queryable of string, because that's what person first name plus space plus person last name produces. That produces a string. And all staff as query syntax, so that's the alternate, gives me really the same thing as the previous one, same 9 items. But I can do them alphabetical, so I can say the staff order by their name. In which case, I'm ordering them by their first name, really. I can use an anonymous type to get an object in there. So here I can get an I-ordered queryable of an anonymous object where I have the first and last name as separate properties and their birth date. And then I could do something like sort them by their last name. Buchanan, Callahan, DeValio, Dodsworth, so on and so forth. Here's a nice one. This one first will give me the first item in a list. Now, if there's nothing in the list, there's nothing on that left-hand side that's empty, then it'll throw an exception. Whereas first or default will give me the default object. So here's the first or default. If I look at the employees, first person named Dan, there are none. So consider this. If I order the list by their birth date, so that's going to order it in ascending order. So I'll get the oldest people at the start of the list. And I take the first, that's the oldest staff member. Or if I look at those people whose first name contains an N, and I take the first one of those, that gives me the first person with an N in their name. However, if I sort the list and then do that first of the first person that contains where the first name contains an N, I might get something different because the order of the staff here would be different than the order when you do explicit sorting. In addition to first and first or default, there's a single and single or default. So the first and first or default expects a list of possibly many items, but only takes the first, of that group of items. Whereas a single and singular default expects only a single item matching whatever filtering, matching the predicate. So here where I do the staff single person, where the person starts with R, that should expect me to have only one. Whereas singular default would give me a default object which would be null. So those are some of the examples of some of those other extension methods with regard to selecting. And I haven't done any examples of doing the where clause, but what I would encourage you to do is to take some of the examples we've done before, like the employees without a manager. And when you run it, take a look at the Lambda version, and you can see how the where clause starts chaining in with items. So it starts with the employees where person such that the person reports to employee is null. Select the person as this new anonymous type. The last little example that I want to show you is number 20. So there is a method called distinct, which will get rid of duplicates. So for example, if I do all the addresses and the cities of all the addresses, you'll see that in that list, if you scroll through, there's going to be some duplicates there. Like here's where London occurs twice, and London occurs a little bit farther on, and Paris occurs twice. So that just gives me all of the cities. If I want to have no duplicates, I could call a distinct on that. So here's all the customer cities. There's 190 of them. But when I look at having no duplicates, I discover that there's only 96 specific cities amongst all the customers. Take and skip are a couple good examples. So I could take the city names where I take the first 5 cities, or I can skip 5 and take 3, the next 3 cities. I have to select more code to make that work. So here's the first 5 cities. And here's the next 3 cities. Again, I've got duplicates in there. So if I did a distinct and then did the taking, that would be a different kind of a set. By the way, take and skip, these are ideal for paging or for pagination, which is where you display results, or where you display X results per page. So if you took the 15-17 from me over the summer, we went on a long road through the whole pagination thing. Took up a bit more time than I was originally planning, but we discovered how that whole problem of figuring out how many items to page on, how many items to show on a page, like when you get Google results, right? You get 5 million results, but they only show you the first 20 or something like that. And then you have to click to the next page, or you jump to page 10 or page 5 or something like that. So that's a good example of that. Any is a good one for checking for any of the items matching the condition. It's also a good one for just determining if there's anything in a list. The difference between any and all is that any will return true if even one of the items matches whatever predicate condition you're putting in there, whereas all will only return true if all of the items match the condition. And here I'm doing it with categories to get different priced items. So let's take a little look at the results. So categories with low price items include beverages and dairy products that have low price items below $5. Categories that have prices over $7.50, where all of them are over $7.50. That's condiments, confections, and produce. Okay, I've done a bit of a run through of all of these extension methods, and it's been to raise your awareness that they are there and to get you examining them and seeing what they do. The trick for you is to be familiar enough with these that you could know when you would choose a particular characteristic of doing link in order to get the results you would want to have. When we do our first take-home exercise, which I'll be releasing probably by tomorrow, that's going to have your a bunch of problems for you to work on to expand your understanding of this. If you haven't finished off the practice questions in this lesson folder, please do those. Make sure you have those done by Wednesday's class. And what we'll be doing is we'll be diving into actually doing our .NET web application starting on Wednesday. So I'll get you familiar with .NET Core web apps with Razor pages, and we'll then start as we learn a little bit of the mechanics of how that works. We'll be going back to the question of how do we create a user interface that's going to be a good experience for the user. And by the way, for that particular exercise, I think about half of the class has got that one done. So that's where I asked you to go and do a sketch or something of a form for entering in customer orders. So if you haven't done that, please complete that. Put that in your workbook. That's going to actually turn around and factor in to the sort of stuff you're going to have to do later on in this course as well. I will gather together answers to the practice questions, and I'll give you some time in class to ask your questions about them. So yes, we'll have a bit of opportunity for that. Okay, well, that's everything for today. I wish you guys a good evening. Take a moment, step outside, get a little bit of sunshine, and I will see you on Wednesday. Bye for now.